Get ready to witness the impossible. China is changing the construction landscape, pushing boundaries with mega projects that leave engineers worldwide in awe. Think colossal dams that generate record-breaking amounts of electricity, tunnels built through impossibly tricky terrain, and bridges that make you feel like you're walking on air. These projects aren't just big, they're fast. China is known for constructing massive highways, sprawling bridges, and sleek high-speed rail lines at mind-blowing speeds. Advanced technology, cutting-edge construction methods, and an unwavering determination fuel this relentless pace. Some might even be shocked by this rapid progress, this ambition that turns blueprints into reality with astonishing efficiency. But how does China do it? What secrets lie behind these engineering marvels? Let's dive in and discover the ingenuity that shapes some of China's most insane mega projects. The first project on our list, and it's a doozy. Imagine a city's busiest highway artery, choked with traffic day and night. Now, imagine the bridge at the heart of this network suddenly becomes dangerous. Traffic can't stop, not for months. It's a logistical nightmare, unless you're a Chinese engineer, apparently. Behold the Sanyuan Bridge Replacement Project. Flashback to Beijing 2015. The Sanyuan Bridge is old, and the traffic load is unbearable. It's literally sagging under the weight. This bridge carries over 200,000 vehicles a day. Replacing it the traditional way would cripple the city for months. Nope, not an option. So here's the plan the Chinese came up with. Picture this, midnight, November 13th. They completely shut down the bridge. What follows is a symphony of cranes, precision technology, and raw power. The old bridge has to come down and fast. First order of business, cut that thing to pieces. Saws slice through concrete and steel, breaking the old bridge into 27 giant chunks. The heaviest weighs about 139 tons. That's nearly twice the weight of a blue whale. Now, the tricky part. This demolition takes place while the old bridge is still partially standing. If we mess this up, the whole thing could collapse. Each of these gigantic chunks has to be lifted off by massive cranes, careful not to disturb the rest of the teetering structure. Talk about high-stakes Jenga. But here's where it gets truly wild. While this demolition ballet is happening, the new bridge is nearby. It's massive, nearly 1,300 tons, fully assembled. How do you move something so big so quickly? Enter the Shen Tuo. Two monstrous Chinese-made transporters. These behemoths have 96 wheels each and can lift insane amounts of weight. See, these machines are linked and synchronized perfectly. They grab the new bridge and start moving it like it's a toy. But here's the kicker. This bridge has to be positioned perfectly onto the old supports. The margin of error, millimeters. They use GPS, lasers, and the whole 9 yards. It's an engineering marvel in real time. Slowly, with agonizing precision, the new bridge slots into place. And get this, from start to finish, the entire process takes 43 hours. Less than 2 days. Beijing's traffic nightmare is averted. This project is a masterclass in speed, innovation, and the sheer audacity of Chinese engineering. It makes you wonder what other mind-blowing projects are just waiting to be unveiled. Stay tuned to find out. Now, buckle up, because if a bridge rebuild in 43 hours impressed you, China's high-speed rail network boasts an even more mind-bending feat, constructing a functional train station in a mere 9 hours. Let's dissect this engineering marvel and see how they pulled it off. First, some context. This wasn't a brand new station sprouting from scratch. The project involved upgrading a crucial section of track near the existing Longyan Station, a bustling hub in Fujian Province. The goal? To seamlessly integrate the station with a brand new high-speed rail line. Imagine the impact. Journeys that once took 7 hours would be slashed to a breezy 90 minutes thanks to these sleek bullet trains zooming at 200 kilometers per hour. Now, here's where the 9-hour magic happens. The key lies in meticulous planning and a heavy dose of prefabrication. Months before the big night, engineers meticulously mapped out every step of the process. Think of it like a high-stakes chess game, where every move needs to be calculated in advance. Prefabrication became their secret weapon. Instead of painstakingly laying the track on-site, pre-assembled sections, complete with sleepers and ballast, were cast off-site in dedicated facilities. Imagine giant Lego pieces for a high-speed railway. The big night arrives, and 1,500 workers descend upon the site with military precision. Time is of the essence. Disrupting a major station like Longyan for an extended period would cripple the city's transportation network. So they work through the night, a well-oiled machine divided into specialized teams. One group focuses on dismantling the existing track, another on meticulously removing the old interlocking system, the complex network of switches that allow trains to maneuver between tracks. Here's where things get fascinating. Remember those prefabricated track sections? They come into play now. Specialized cranes and rail-mounted machinery, pre-positioned for maximum efficiency, swing into action. The pre-built sections are carefully lifted and slotted into place with laser-guided precision. It's like watching a construction ballet, every movement synchronized to avoid any delays. Meanwhile, another crucial task unfolds. Skilled electricians meticulously rewire the entire section, ensuring seamless integration with the existing signaling system. These guys are the unsung heroes, making sure trains can navigate the new track safely. As the prefabricated sections are laid, other teams tackle the ballast, the layer of crushed rock that provides stability to the tracks. They use specialized machinery to spread and compact this crucial layer, ensuring a smooth ride for future high-speed trains. With clockwork precision, the teams work through the night. The old interlocking system is replaced, the prefabricated track sections are secured, the ballast is compacted, and the electrical connections are complete. As dawn breaks, they take a collective sigh of relief. The impossible has been achieved. A fully functional section of track, ready to handle the high-speed behemoths, has been built in a mere 9 hours. If you thought a 9-hour train station was impressive, buckle up. China took on a maritime challenge of epic proportions, designing and constructing the world's longest sea crossing, the Kong-Zhuhai-Macau Bridge. This behemoth, stretching a mind-boggling 55 kilometers across the Pearl River estuary, isn't just about convenience. It's a linchpin in China's ambitious plan to transform the Greater Bay Area, a network of 11 cities, into an economic powerhouse. Here's where engineering ingenuity meets ambition. This wasn't a simple bridge build. Picture the challenges: frenetic shipping traffic, the wrath of typhoons, and delicate marine ecosystems, particularly those of the iconic Chinese white dolphins. The solution? A complex feat combining bridges, tunnels, and artificial islands. Let's focus on the main bridge, a 29.6-kilometer marvel in itself. To minimize disruption and preserve those dolphin habitats, engineers opted for slender, single-column piers anchored deep into the seabed. Above the waves, 3 cable-stayed bridges, each with unique, sail-like towers, rise to support the massive carriageways. It's an aesthetic statement as much as an engineering achievement. Now, about those artificial islands. These aren't just mounds of sand dumped into the sea. They've meticulously engineered structures crucial to the bridge's functionality. They seamlessly transition traffic from colossal bridges to a 6-kilometer-long underwater tunnel. Think of them as giant traffic interchanges in the middle of the ocean. Speaking of underwater tunnels, this project features one of the most complex ever built. Instead of boring through solid ground, it's made of 33 massive concrete sections, each weighing a staggering 80,000 tons. These sections were carefully lowered into place, forming a massive underwater highway. It's a testament to the precision and power of Chinese marine engineering. And let's not forget the logistics behind this mega project. Coordinating massive construction teams, specialized machinery, and the movement of building materials across land and sea over a 9-year construction period is a ballet of planning and problem solving. The result? A journey that used to take hours by ferry now takes a mere 40 minutes by car. The ripple effects are huge: increased trade, a boost to the tourism industry, and the symbolic binding of major cities into a future regional powerhouse. The Beihetan Hydropower Station, a testament to China's clean energy ambitions, stands as another megaproject that reshapes our understanding of renewable power. This beast of a power plant boasts an installed capacity of 16,000 megawatts, capable of generating over 62 billion kilowatt hours of electricity annually. But the real story lies in the engineering feats behind its construction. Let's start with the heart, the turbines. Beihetan breaks records by sporting 16 gargantuan 1,000 megawatt hydroelectric turbines, the largest ever built. Forget numerous smaller turbines. This approach means lower installation costs, reduced maintenance, and a jaw-dropping energy conversion efficiency of 96.97%. But how did they pull off designing and building such behemoths? Deep within each turbine, a complex water guide mechanism dictates the incoming flow of water. It's a critical component for stability and efficiency. SKF's sealing technology plays a pivotal role here. By minimizing water leakage around moving parts, they've slashed theoretical leakage levels to a mere tenth of what's typical for such massive turbines. This ingenuity directly translates to greater power output. Now, let's venture outside the turbines. The force these machines generate is held back by a colossal 289-meter concrete arch dam, the height of a 100-story skyscraper. This isn't just about keeping a lake in place. This structure withstands an unimaginable hydraulic force of 16.5 million tons. It's meticulously engineered to function safely under extreme floods and earthquakes. To control water flow under emergency conditions, a massive quick-energy gate relies on the world's biggest hydraulic hoist. This beastly cylinder, with its ceramic-coated piston, can lift the equivalent of 800 cars. Inside, SKF's specialized spherical bearings ensure smooth operation and exceptional load-bearing capacity despite the harsh, humid environment. But it's not just brute force, it's about precision. SKF sealing technology keeps this hoist functioning flawlessly, preventing hydraulic fluid leaks and protecting internal components. Specialized materials with anti-friction and anti-creep properties are vital for long-term reliability under the relentless pressures of this environment. The Beihetan Hydropower Station isn't just a source of clean energy, it's a marvel of modern engineering. From the awe-inspiring scale of the Beihetan Hydropower Station, let's shift gears entirely and focus on the lightning-fast construction of a medical marvel, the Huoshenshan Hospital, built in Wuhan, China in a staggering 10 days. Imagine battling a rapidly spreading virus with limited healthcare resources. That's exactly the situation Wuhan faced at the beginning of the COVID-19 pandemic. To effectively isolate and treat patients, the need for a dedicated medical facility arose with unparalleled urgency. The Huoshenshan Hospital wasn't built from scratch. It was strategically constructed on the pre-existing logistics site. This smart choice saved precious time on land acquisition and initial groundwork. However, the real marvel lies in how they transformed this empty site into a fully functional hospital in a mere 10 days. The answer lies in prefabrication, a construction technique where key building components are manufactured off-site under controlled conditions. Think of Lego blocks, but for hospitals. Prefabricated wall panels, pre-assembled piping systems, and modular patient rooms arrived on-site ready for rapid assembly. This eliminated the need for on-site bricklaying, welding, and other time-consuming construction processes. But prefabrication is only one piece of the puzzle. To achieve this rapid construction, a staggering workforce of over 7,000 skilled laborers worked around the clock. Imagine a well-oiled machine, electricians installing pre-wired panels, while plumbers connected pre-assembled units. This coordinated effort ensured minimal delays and maximized efficiency. Here's where the numbers become truly staggering. The hospital sprawls across 34,000 square meters, boasting 1,000 patient beds spread across 2 floors. To achieve this in 10 days, workers laid an average of 2,500 square meters of prefabricated panels every single day. That's the equivalent of building a new house every few hours. But how exactly did these prefabricated components come together so quickly? Months before the outbreak, Chinese authorities had begun investing in prefabricated construction facilities specifically for emergency response situations. These dedicated factories were already churning out standardized wall panels, pre-configured plumbing units, and even modular operating rooms long before the crisis in Wuhan unfolded. This foresight proved invaluable when the need for the Huoshenshan Hospital arose. With the prefabrication facilities humming, meticulous digital planning took center stage. Advanced 3D modeling software allowed engineers to virtually design and assemble the entire hospital down to the last detail. This digital blueprint ensured all prefabricated components, walls, floors, piping systems, would fit together seamlessly, minimizing the need for on-site adjustments and delays. Delivering thousands of prefabricated components to the construction site in a timely manner was a logistical nightmare. A sophisticated system was established involving dedicated trucking routes, prioritized clearance at checkpoints, and a meticulously planned unloading sequence at the construction site. This ensured a steady flow of materials without bottlenecks or delays. While the prefabricated components were being manufactured, the existing logistics site was being prepped for rapid assembly. Bulldozers leveled the ground, foundation slabs were poured, and utility trenches were dug, all meticulously planned to minimize disruption when the prefabricated units arrived. The construction workforce itself deserves a standing ovation. Over 7,000 skilled laborers, including carpenters, electricians, plumbers, and ventilation specialists, descended upon the site. Each team had a specific role. Some focused on erecting prefabricated walls, others on connecting pre-assembled piping systems, and others on installing vital medical equipment. The division of labor and the workers' expertise ensured a smooth and rapid assembly process. The Huoshenshan Hospital wasn't just about speed, it was about functionality. Dedicated isolation wards with negative pressure ventilation systems prevented the spread of the virus within the hospital. Advanced medical equipment, including respiratory machines and diagnostic tools, arrived alongside the prefabricated units, ensuring the hospital was operational as soon as construction was complete. Building a hospital in 10 days might seem like science fiction, but the Huoshenshan project is a very real example of what's possible when the human ingenuity meets innovative construction methods and unwavering determination. China stepped into the African spotlight in 2003 when it began construction on the Mero Dam, a behemoth aiming to be the largest contemporary hydropower project in Africa. This colossus stretches across the Nile River in Sudan, roughly 350 kilometers north of the bustling capital, Khartoum. But the Mero Dam isn't just about size, it's a marvel of modern engineering, harnessing the Nile's mighty flow to generate electricity for millions. At a staggering 9 kilometers long, the dam's sheer scale is enough to steal your breath away. Imagine a wall over 5.6 miles long, its crest reaching up to 67 meters. That's taller than a 20-story building. But the dam isn't a single, uniform structure. Chinese engineers designed it with a multi-pronged approach to maximize efficiency and stability. The core of the dam lies in the left river channel, where an 883-meter-long earth-core rock-filled dam stands guard. Picture a giant mound of earth and rock, its core meticulously compacted to form an impermeable barrier. This isn't the only line of defense, though. Flanking the earth core dam on either side are massive concrete-faced rock-fill dams. The right bank boasts the larger of the two, stretching 4.3 kilometers and reaching a height of 53 meters. The left bank's dam isn't far behind, clocking in at 1,590 meters long and 50 meters high. But dams aren't just about holding back water. They need to control its flow for power generation. This crucial role falls on the dam's live water section, situated on the right bank of the Nile. Here, a network of sluices allow for controlled water release, while a 154-meter-long spillway ensures safety by providing an overflow channel during periods of high water levels. However, this section's crown jewel is the 300-meter power intake dam, which houses the turbines that convert the Nile's energy into electricity. Speaking of turbines, the Meroe Dam boasts 10 125-megawatt Francis turbines. Each of these mechanical marvels is designed to handle a flow rate of 300 cubic meters of water per second, a mind-boggling amount. Imagine 10 giant water wheels, each spinning with the force of a raging river, churning out a combined potential electricity yield of 5.5 terawatt-hours annually. To handle this surge of power and distribute it across Sudan's vast network, a massive upgrade of the country's electrical grid was undertaken alongside the dam construction. This ambitious project involved laying over 1,500 kilometers of new transmission lines, including a 500 kilovolt aerial line that cuts across the Bayuda Desert to reach Atbara, Omdurman, and Khartoum. Further east, 220 kilovolt lines snake their way towards Port Sudan, while others head west along the Nile, connecting Meroe to Daba and Dongola. But beyond its grand scale, the Meroe Dam is a complex feat of design and construction, where every meter of the dam wall, every cubic meter of water flow, and every megawatt of electricity is meticulously calculated to achieve optimal efficiency and performance. China's reputation as an infrastructure powerhouse comes from its boldness, a willingness to tackle projects that others deem impossible. One such challenge was the Humaling Tunnel in Gansu Province, labeled the most difficult tunnel to build. A mere 173 meters of this tunnel left engineers worldwide stumped, even after Germany, a nation renowned for its engineering prowess, threw in the towel. Yet, China persevered, and after 6 long years, the seemingly impossible tunnel was finally completed. So, what made the Humaling Tunnel so uniquely problematic? It all boils down to geology and location. This tunnel wasn't just cutting through solid rock. Its path crossed a reservoir and a river, saturating the surrounding earth. The soil was predominantly loess, a notoriously loose and unstable material that tends to liquefy when disturbed. Think of trying to tunnel through quicksand. Imagine the scene. Digging commences and the soil around the tunnel starts to crumble and shift. Cracks appear, threatening to collapse the entire structure. To make matters worse, heavy rains would further destabilize the ground, potentially leading to catastrophic cave-ins. Safety concerns loomed with every meter of progress. With conventional methods proving ineffective, China sought the help of international experts. But expert after expert, faced with the Humaling Tunnel's loose, waterlogged earth, was left scratching their heads. No feasible solution was in sight. The tunnel quickly became a symbol of engineering's limits, appearing on lists of the world's most intractable construction problems. It earned the nickname Tofu Tunnel, highlighting its frustratingly fragile nature. But China wasn't about to give up. Determined engineers devised a daring plan, combining innovative technologies and meticulous execution. They adopted a cautious, step-by-step excavation method alongside vacuum dewatering to stabilize the soil. The work was fraught with danger. Sudden surges of water and sand into the tunnel became a terrifyingly common occurrence. Over 6 years, a team of 1,200 workers toiled in shifts to overcome the challenges. Progress was painfully slow, averaging a mere 2 to 3 meters per day. The harsh climate added further hurdles. In icy winters, an entire team was dedicated to ice breaking to prevent the waterlogged soil from freezing over, which could halt construction entirely. But perseverance paid off. Finally, after 6 grueling years, the Humaling Tunnel was complete. News of its success echoed around the world. It became a testament to Chinese engineering ingenuity, a symbol of the nation's refusal to yield in the face of immense challenges. The Humaling Tunnel, while small in size, represents a massive victory for China. It filled a critical gap in the Lanwu Railway, a lifeline connecting the Yellow and Yangtze River basins. Its economic impact ripples across the region, boosting trade and tourism along its route. Picture the mighty Yangtze River, once a force of nature, carving its way through the breathtaking Hutang, Wu, and Xiling gorges. Now imagine this untamed river harnessed, its power transformed into electricity and a navigable highway through the heart of China. This vision became a reality with the construction of the Three Gorges Dam, an engineering marvel that stands as the world's largest hydroelectric project. This dam is nothing short of colossal. It spans a mind-boggling 2,335 meters across the river and towers 185 meters high. To create this behemoth, engineers used a staggering 28 million cubic meters of concrete, enough to fill thousands of Olympic pools, and integrated 463,000 metric tons of steel into its monolithic structure. But the Three Gorges Dam isn't just about size. It's about reshaping a landscape to unlock the river's potential. The dam's construction flooded the 3 scenic gorges, creating a vast reservoir that stretches 600 kilometers upstream. This new deep-water highway allows massive ocean-going freighters to sail over 2,000 kilometers inland from the East China Sea all the way to the bustling city of Chongqing. Think of the logistics required to navigate this massive dam. Engineers designed a series of 5-tier ship locks capable of lifting and lowering vessels weighing up to 10,000 tons. For smaller ships seeking faster transit, there's an even more incredible feat of engineering: the world's largest ship lift. This colossal elevator for boats bypasses the locks, ensuring swift passage past the dam. The heart of the Three Gorges Dam lies in its power generation. Deep within its massive structure, 32 powerful turbine generators spin with the force of the Yangtze, turning the river's flow into electricity. These turbines make the Three Gorges Dam the most productive hydroelectric power station on Earth. In 2020, it generated a record-breaking 111.88 terawatt-hours of electricity, enough to power millions of homes and fuel China's relentless growth. The Three Gorges Dam was also built to provide a vital defense against the devastating floods that historically plagued the Yangtze Basin. Constructing a project of this scale was an epic undertaking. It involved displacing communities, excavating over 100 million cubic meters of earth and rock, and pouring millions upon millions of cubic meters of concrete. This colossal construction site buzzed with thousands of workers, a testament to the sheer human effort and engineering feats required to tame a river and transform a landscape. China isn't just about massive dams and colossal power plants. Sometimes its mega projects are built on a foundation of audacity and glass. Have you ever dreamed of walking on air? Picture yourself suspended 300 meters above a breathtaking canyon, a mere sheet of glass separating you from the vast expanse below. That's the spine-tingling experience of crossing China's Kong-Zhuhai-Macau Glass Bridge, the world's longest and highest glass-bottomed pedestrian bridge. This marvel of engineering pushes the boundaries of both construction and perception, creating an illusion of weightlessness that will leave you in awe. Stretching 375 meters across the Kong-Zhuhai-Macau National Park, this transparent walkway is supported by massive steel girders filled with reinforced concrete. The bridge weighs a colossal 2,200 tons, a reassuring heft for those who dare to tread on its glassy surface. With a budget of around 460 million yuan, roughly 48 million pounds, no expense was spared in ensuring both its beauty and its safety. The true magic of the bridge lies in its glass deck. It's constructed from a triple layer of specially hardened glass, each layer a substantial 50 millimeters thick. This isn't the kind of glass that shatters at the slightest tap. To prove its resilience, engineers conducted the ultimate stress test. They drove a 40-ton truck over a glass panel, resulting in a mere 2-centimeter deflection. They even invited people to smash the glass with hammers. While the top layer shattered as expected, the crucial bottom layers remained intact, an undeniable testament to the bridge's strength. However, building a see-through bridge at such heights presented unique challenges. Wind forces at that altitude are a major concern. The original design featured glass handrails, but that idea was quickly abandoned. Those railings would have acted like sails in strong winds, potentially destabilizing the entire structure. To combat this, discrete steel poles were used instead, allowing winds to pass harmlessly through and minimizing vibrations. Safety features go beyond the sturdy construction. Giant glass balls, each weighing a hefty 500 kilograms, hang beneath the bridge to dampen vibrations. Massive water reservoirs further stabilize the structure. Finally, strategically placed bends in the railings break up the rhythm of walking pedestrians, preventing the kind of resonant vibrations that famously plagued London's Millennium Bridge when it first opened. These features ensure that Kong-Zhuhai-Macau Glass Bridge can handle both the crowds of thrill-seekers and the whims of nature. The result is a bridge that offers more than just a terrifying walk. Bungee jumpers can now plunge towards the canyon below, adding an extra layer of adrenaline to the experience. But what makes this bridge truly unique is its ability to make you feel like you're floating in midair. As you step out onto the transparent glass, the world seemingly drops away beneath your feet. The focus isn't on the bridge itself, but on the breathtaking expanse of the canyon, giving you a bird's-eye view that's both exhilarating and slightly mind-bending. It's a testament to the power of engineering and design, working together to create an experience that transcends mere construction and transforms into an unforgettable adventure. China's ambition knows no bounds. These mega projects are just a glimpse into their engineering prowess. Know any other mind-blowing projects? Share them in the comments. Like, share, and hit that notification bell for more.